Southeast Radio's Business Matters with Carl Fitzpatrick.
Southeast Radio.
Well, could a mechanical tree be the solution to addressing climate change? Paul Móráin from Carbon Collect certainly believes that they will help, and he joins me now to discuss this innovative idea. Paul, you might start the interview by providing us with an insight into your own background.
I left Ireland, must be back around 1990, moved to London. I've spent most of my career since in the tech sector, so starting off in what's called the digital document sector, and a combination of doing consulting, strategic market consulting and corporate venturing. So I've worked with most of the big tech players on a global basis. That work has taken me across the US, Europe, Eastern Europe, Middle East, so fairly international background. And more recently, I've been a bit more, if you like, involved back in Ireland. I have a number of state organisations. I sit on the board of the HEA, and I've spent a number of years on the Export Trade Council.
So you're now the CEO of Carbon Collect, which recently changed its name from SKH. But how did this company first come on your radar?
So the technology is actually a technology developed at Arizona State University in the US. I've had quite a lot of, if you like, relationships across the international education sector for a number of years. I was involved initially in setting up some, if you like, research relationships between Ireland and Arizona State University, and in addition to a number of other European countries. And the technology around carbon capture kept coming up in conversations, which prompted us to take a closer look. And at that stage, we started the conversations with Dr. Klaus Lackner, who is the inventor of the technology.
So, Paul, provide us with an insight into the technology that Dr. Klaus Lackner in Arizona State University developed.
Dr. Klaus Lackner is the originator of what we call direct air capture on a global basis. He started looking at this in around 1992, just the whole challenge of, what's driving climate change, what do emissions mean to the atmosphere, and so on. And by 1999, he had formed an opinion that we need to take carbon dioxide from the air to deal with climate change. And his early work was just demonstrating the science that you can actually physically do that.
So provide us with an insight into how Carbon Collect has actually commercialised that work.
The process that we're following is we're building the first mechanical tree, which will be installed in Arizona later this year. We will move from there to building a cluster, which is 12 mechanical trees, which will take 1 ton per day out of the atmosphere, and then develop onwards to capturing or developing 480 trees, mechanical trees, to take, if you like, a wider body of air. And that farm cluster, which we refer to it as, that will take, that will form the building blocks, if you like, for the large iterations of these mechanical tree farms.
Now, of course, we've heard lots about wind farms and solar farms in recent years, but this is a first on me. So talk to us about how they actually work.
The science is actually quite simple. So we have, different iterations of direct air capture systems, and all of them go back to the early work of Dr. Klaus Lackner. Some of them use a wet sorbent, which requires a very high temperature process. And some of them use what we refer to as solid sorbents, which can be operated at lower temperatures. Most of the systems use a lot of energy because you're sucking in air using fans and blowers. You're creating pressure and blowing it across these sorbent beds. And what we have is what we refer to as a passive system. So in difference to those other systems, we just have these trees, mechanical trees that stand in the wind. We have wind blowing through a stack of discs with the sorbent, solid sorbent. And these sorbents attract CO₂, and they let the air, the main body of air just pass through.
And what materials are these mechanical trees made from?
The first mechanical tree we're building completely in metal, and there's a number of reasons for that. One, it's our, if you like, demonstrator. If we need to add in an extra piece of instrumentation or another gauge, we can actually drill in metal without damaging the integrity of the machine. And it's really, it's commercial scale, so it's full scale. The dimensions, when it's in its regeneration position, when we're taking this CO₂ off, it's about 2.5 meters high and about 1.5 meters in diameter, so barrel shaped, if you like. And it extends upwards to about 30 feet when it's capturing the air.
And who will your clients be in relation to this particular product?
Well, as you would have seen, particularly over the last year, we have this rush by both governments and large corporates and polluters to make all sorts of promises around decarbonisation and getting to net zero. So that's really the market we're going to be playing in long term. In the short term, we can play to a smaller market, if you like, where we're capturing and reusing the CO₂. So in that small starting point, if you look at carbonated drinks companies, beer manufacturing companies, food growers, industrial processes, we can actually capture CO₂ on site for direct use on site by those users. As we get into the climatic market for CO₂ capture and disposal, then we're talking about underground storage of the captured CO₂. And that's where those net zero pledges and the low carbon pledges come into play.
And Paul, from an investment perspective, do you need international governments to get on board to make this viable?
If I separate out the investment side from the longer term deployment side, so we have currently raised our investment from investors in the UK, Africa, and the US and Ireland. So those are, well, actually in continental Europe as well. So Europe, US and Africa, those sort of three locations. In terms of deployment and the cost of deploying this type of technology, then we would envisage that the large-scale farms would be, if you like, if you take the traditional waste management industry, if you look back 20, 25 years ago, it was a very simple process. You put your garbage out, the truck came along, picked it up, it went to a landfill site, and it was dumped in the ground, and no one really cared about it. And if you look at the whole evolution of that industry since, where you have a lot of technology coming into play, you have the polluter pays principle, so you pay for your garbage to be collected and disposed of. But it generally goes to a factory, gets sorted. You have everything from, machine vision to do sorting. You have very smart systems to manage the process, and you end up with a very small amount going, to ground. But if you look at the revenues and the job creation behind that industry, it's quite substantial on a global basis. And we would envisage that this is a similar pathway, that you have carbon dioxide, which is essentially a waste byproduct of processes, and it's currently being dumped in the atmosphere. Now, if it had mass that you actually see, if it's out on the ground and it had a colour, people would not accept just that level of waste being dumped the way it is right now. So the logical step is that we move the same path as for the traditional waste management industry, where the polluter pays.
And are there any locations in Ireland currently being considered by you for these mechanical trees?
We're interested and we're exploring the potential to have some early iterations of this. And, if you look around at what's happening in Ireland right now, you have, if you like, the discontinuation of, the operations of Bordnamona as an example. There are a lot of brownfield sites in Ireland that could be utilised, particularly where you have a power station and that's being decommissioned. We're not talking about substantial land footprints. If you take those 4 million tonne per year farms, we're looking at a land footprint of about 2 square kilometres as an example. And I believe Ireland's carbon emissions per year as a country is something like 60 million. So if we're doing 4 million tonnes per year of capture on a single site, that's actually quite significant to helping Ireland get down the path to its carbon commitments.
So what is the future growth plan for Carbon Collect, and how do you intend to get there?
The whole focus for us, everything we're doing is around ultimately, having, if you like, an eye on the cost of capture. So as a company, we have to remain as lean as possible. Everything we do, predicates on that eventual cost of capture. There's no point in being in this industry if you're going to be small scale. So our ambition is to be very large scale in as short a time as possible. So in practical sense, we're looking at the second half of this decade to be in a position to, if you like, to deploy those very large carbon farms. And the benefit of the technology is we can start small. So rather than burning investor cash indefinitely at the early stages, we can actually supply a single mechanical tree to a small use case.
Well, if you've just tuned in, that was Paul Móráin from Carbon Collect. And the transformative potential of these mechanical trees is very exciting and definitely one to keep an eye on.
Southeast Radio's Business Matters with Carl Fitzpatrick.
Southeast